Again, we have three great speakers that Andy has put together for today. First, we're going to have Christian Gass from Civic Mapper. I know many of you have known Christian. He's presented, I know, several times to us, and he's going to highlight the usability of the system and how we continue to try to make it more user-friendly for everybody. We have Jean from View. Personally, it's the first time I've got to meet Jean. I'll see her today here, and Jean provides the calibration and the QA/QC and some other things for us. She's been with us for a good while with this system. And then we have our good friend Tim Prevost from Alcosan, who's going to talk about the physical. Hey Tim, the physical part of it, that his team helps us maintain it and everything else. This system, RainGauge system, was installed about 20 years ago throughout the county, and I want to especially thank Tim today and Alcosan for helping us fund. They are providing funding to upgrade the system physically. We'll be putting new monitors in, and so special thanks to Tim for pushing that, and Alcosan for providing the funding. I couldn't do it without them. They're a great team to work with. And then Annie has put together, and she'll introduce them as they come up. Annie's put together some three individuals who use the system quite frequently and how they use it for their communities. So I think together we've put this great presentation together. So without further ado, we're going to turn it over to Christian.
Hi, everyone. Just getting my screen set up here. So thanks, Dave, for the introduction. What I'm going to do today is kind of give folks a refresher on how Three Rivers is serving up the rainfall data from DataWise, Alcosan, and View in July 2021 here. We presented in January, so for anyone who was on that webinar in January, this will look pretty familiar. There are a few little differences, and I'll try to highlight those. But if this is your first time, then we got you covered here. And then I'll talk a little bit about how we're road mapping out just the kind of user experience for downloading some of this information. So to start with, if you're on the Three Rivers wetweather.org website, to get to rainfall, you're going to go to their top menu, over to the resources menu, and then down to calibrated radar rainfall data. And this is basically where this has always lived. On this page, you can scroll down a bit, and we have a big link to the Start the Rainfall Tool button here. And when you click that, it'll take you over to an external site we hosted on GitHub for Three Rivers. Where the viewer lives. What you'll notice right off the bat is that this app is it's made possible with the great data we get from View, from Alcosan, and from DataWise. So we're aggregating that data, we're presenting it back to you, and we're trying to make that kind of as easy as possible for you to get to. If you scroll down a little on this About screen, it'll just give you a quick summary of the types of data that you can get here. It really comes in three buckets, and these buckets exist because of the way the previous site was set up and kind of named things. We're thinking about how this might change, but in any case, currently bucket 1 is real-time provisional rainfall data, so that's gauges and radar pixels grouped together. Second bucket is historic rain gauge data, and this has been QA/QC'd. It's any data gaps due to telemetry issues or transmission issues have been addressed. And then the final bucket is the calibrated radar rainfall data, which is that gauge adjusted radar rainfall data that View provides. So those three buckets on the screen, if you close out of that, correspond to the three tabs at the top of the screen. And each one of those is sort of just a different context for doing the work of downloading the rainfall data. And if you click on each one, you'll notice that things kind of look the same. There's a little description to prompt you, to show you what's going on. So what I'm going to do is walk through just how to get data from this, and it applies to all three of these. Just quickly, you'll you'll have noticed that there's a map on the left side of the screen. It's interactive. You can pan and zoom. It's a web map. It also has a little search if you need to get to somewhere specifically. And today we're just going to fly to Three Rivers office in Lawrenceville, and it'll take us right down there. On the right side of the screen, there's really three parameters: the when, the where, and kind of how often that you're able to pick when you get the rainfall data. Because we're looking at real time right now, and we had a good bit of rain yesterday, we'll use this little calendar picker to just show us the past 24 hours of rainfall data. And then we'll pick our sensor. So Three Rivers has a gauge on their office, and they're part of a Pixel virtual gauge 150136. There's a few ways now we can get to this, and this is different from what you would have seen in January. You can pick your gauge from this drop down here. You can search for it by typing if you want. And same with the radar pixels. Now previously we were letting you pick basins and we're limiting you to that. Now you can pick any pixel one at a time. And I'll go into what else we're going to do with that too. But for now, you can pick from those drop downs, or you can actually select on the map by clicking on basically anything. And that'll make your selection there for the geographies you're interested in. And we'll leave the interval at 15 minutes. So that's the way the data is natively stored. It's aggregated in 15-minute intervals. And we'll press that Get Rainfall Data button. For single queries, it's usually pretty fast. Once you start adding lots and lots of pixels, it'll slow down. But in this case, that came back nice and quick. By default, it's symbolized on a 0 to 5 inch rainfall scale, but the legend at the bottom of the screen will let you kind of recalibrate that. We have lots of ways we could take this in terms of letting you set dynamic symbology and things for your maps, but just to give you a quick visual cue, there that is. Now the downloaded data is ready. There's a button here that says View and Download Results. And that'll show you just a sample of the tabular data you're going to get, and has a download as CSV button. In the future, we also hope to add a download as spatial format button, so you could load this straight into mapping software if you want. But for now, we can hit that download as CSV. If you're set up to open these kind of files in spreadsheet software, it'll do that right away for you, and you'll get it. Now, what you'll note, if you recall, from a few years ago in the old site, the data used to be provided in a crosstab format where each row was a single point in time and each column was a sensor. We're providing it instead in a observation format. So it's every row is every timestamp for every sensor. What this lets you do and gives you the flexibility to do is actually kind of render it however you want. I like to do a pivot table. It's nice and quick. You can select all that data. Pull it in, we can add a filter by type, put our timestamps in our rows, put our sensors, our columns, and we only had the 2, and get our sum. We can look at rainfall over time and our totals for that area. Nice and quick. In the future, we hope to have this kind of data visualization functionality built right into the app. We actually have a placeholder for that under here for graph. But for now, there's a little coming soon note.
Christian, this is Dave. I have a question for somebody that's really not used this system a lot. The 0.05 and the 5 and the 10 down in the left-hand corner, what does that, what is the significance?
That's just going to set the max range on the legend. So how the rainfall results are shown on the map, or essentially how they're colored on the map. This actually goes back to a way it was done in the previous site. If there's a lot of variability in rainfall in the region, and at some point we're going to be able to get you to download all the pixels for the region, you'd be able to see that maybe better, or focus in on different areas just based on adjusting that. Potentially we could have that be a free-form number, show set your min and max, and it'll show all the values clearly within that range, but purely legend control. So The workflow I just showed for the real-time rainfall data is the same for going back and getting the historic rain gauge data and for the calibrated radar rainfall data. The one thing we do have for those that we don't have for real time is actually a list of rainfall events. These come from the reports that View provides through Rivers on a monthly basis. And with that, we can basically shortcut the selection of a time frame for you when you're getting that historic data. It's really just a convenience. And it's interesting, it goes all the way back 20 years or so. Now, so that's the workflow. Should you find yourself on the site later today or next week or next month, and you need a little more guidance, there's an About button in the top right-hand corner of the site. You can click that. It'll take you back to that screen that you saw when we loaded up. And there is a Getting Data tab, which walks through somewhat coarsely for now, but we'll make this a little more friendly. The steps that I just described, getting the time, selecting the timestamp, the location, your interval, and then getting the data and then what you see when it comes out. I also want to point out under here too that we're providing the webinars, and we'll put today's webinar up here as well, so you can go back and watch what I'm talking about right now at a later point if that's helpful. And additionally, we have a little section called Under the Hood, where we provide some information about what is powering this. Behind this web app is an entire other web app called the Three Rivers Wet Weather Data API. It serves up the rainfall data, and it gives us the flexibility to do some fun things with the rainfall data. We provide a usage example, a link to a usage example for those who are getting their hands dirty in code, and we know there are a few folks out there who ask about doing that, so we provided an example here. And I mentioned at the beginning of the presentation that we have a lot of ideas about where to take this to, and from this tab here you can actually get to the project's roadmap, which is on GitHub here. And here we're documenting features, ideas, some specific, some general. And we'd actually encourage you to come on here, and if you have an idea, you're actually able to submit it here, or you can always do that by email too. Or if you encounter a bug or an issue, because this is a beta tool, you can file it here as well. And we're really open to kind of doing anything with the site, as long as Dave lets us. Last week we were bouncing around the idea. We thought, well, wouldn't it be cool if we could just ask Siri and she would get how much rainfall data we had for our location. So if you say something like, how much rainfall in the past 24 hours, she might be able to respond to you. And actually, why don't we try that? How much rain in the past 24 hours? Of course, live demos never work, so what I'm going to show you is my camera. If you can see it.
Can't see it.
Can't see it.
It's all blurry.
It's all blurry because it's not a human face, right? In any case, that would have been really cool if it worked. So we're going to try that one more time. Well, how much rain in the past 48 hours?
One thing that Dave wants is it to be the most user-friendly document we can have. So
0.5 inches of rainfall over the past 48 hours. For more information about rainfall and infrastructure in the greater Pittsburgh area, visit www.threeriverswetweather.org. There we
go. So we're open to any kind of crazy ideas. That's the flexibility of kind of building the app the way we did. We can serve up kind of things that are specific to your use case. And so we encourage you to get in touch with us to do that.
Christian, in the meantime, I show that Sam Shamsi has his hand up. Do you want to take questions now or wait till the end?
Sure, yeah.
Go ahead, Sam. You're muted.
Can you hear me now?
Yes.
Yes.
Hey, Christian. I have 2 questions on behalf of modelers.
Okay.
I'm a modeler myself, and I think one of the good uses of this data is for hydrologic and hydraulic modeling And it is pretty relevant right now because, Three Rivers Wet Weather has done a lot of presentations over the last couple of months about percent capture calculations, and they all come from modeling. So the first question is related to modeling, is that modelers are interested in calculating the rainfall for an area rather than a point. They can pick a point in the middle of that area, but in Pittsburgh, there's so much variability in rainfall. So for example, I work in the city, and yesterday it was not raining here, and I checked my app, and it was raining hard in where I live in Robinson Township. So can you pick multiple pixels or multiple gauges using the process you showed? And hold off to your answer, because second question may be related to your answer. So you can maybe answer both of them together. So second question is that, once we pick one or multiple gauges, the goal is to put them into our model, which is called SWIM, the Stormwater Management Model. It is from EPA, and everybody in this area uses the same model. So is there a way for somebody to pick their area, either by defining a polygon on the screen or inputting a shapefile for the area, and then create a model input file? So it will reduce their post-processing work after they download the data from you. And I'll be happy to work with you to show what kind of format the data goes in SWIM. It's very close to how you created your Excel file, very, very close to it. It wouldn't take too much programming effort. So those are my two questions.
Yes. So in terms of selecting more than one location, yeah, absolutely. The demo we showed in January, we had instead of picking by pixel, we had pick selector by basin. That's out for the time being, but it will be back in, and it won't just limit you to basins. It'll, as a start, let you pick by municipality and watershed, or any combination of those things and gauges. And what that'll do is provide a shortcut to picking the pixels, so then you don't have to select them individually. In terms of uploading, we've been thinking about that too. It's probably a little longer term to provide your own kind of geometry file, but that's definitely a possibility. And certainly also just having the ability to kind of lasso an area, draw it on screen, so to speak, temporarily, just to pick those pixels rather than click each one. That's all feasible. For getting data in a SWIM ready format, it's funny, we talked with some folks at Cosmos a few years ago about doing just that, with not just rainfall, but all of Three Rivers data. And that became the basis for the Rainways kind of reboot that we've been tasked with this year. So the idea is get that rainfall data in that input file ready format, get topographic data, any wastewater data or anything like that, anything else you need really from the system, get it all out into that format. So would definitely be happy to have that conversation with you, and we can start with rainfall.
Thank you.
Christian, this is Annie. I don't see any other additional comments, and so I really appreciate your how-to presentation this morning, and want to thank you. And I think we should jump over to Jean, who is at View and going to give us some of that more technical data background. So thanks, Christian, and take it away, Jean.
Hey, thank you. I see a lot of familiar names, so I think some of you know me and I know some of you. Trying to find myself here. Not presenting what I want to present. I'm going to pull this over to this. Can you see my PowerPoint, or have I got the wrong?
We see your web application. It looks like it might be your browser. I did see a PowerPoint a second ago though, but it wasn't in present mode.
Okay, I am in the right place then. I'll bring it back and I'll get going. Looks good?
I see a PowerPoint now. Yes, you're great.
Okay, so hi guys, I'm Jean View, president. I've been project manager at Three Rivers for forever, since about 2002. I've got Jennifer French and Dr. Kelsey McDonough on the call with me because they're going to be taking over more and more project management responsibilities as time goes on. And Jen already knows your data very well. She is a native of Pittsburgh. She actually lives in New York now. She's a meteorology graduate of Penn State and then a master's in meteorology at the University of Oklahoma. And she's worked with us for the past 14 years, giving us great data quality control and managing her team that does that. We're subject matter experts. So Kelsey's a PhD in engineering and hydrologic applications of radar rainfall. So they both are very intimately involved in the kind of activities we do. So View and Three Rivers, I have one slide on that telling you a little bit about the data background and then where the data comes from and how we process it. And then finally our View information platform that is an internal tool that's more of a professional expert tool, not on a public website. So we've been working with Tim Prevost and Joe and the Alcosan and Three Rivers team since about 2002. And at that time, we started providing 15-minute end-of-month quality GAR, along with the DDF analysis for qualified rainfall events. And this system has evolved over time, so it's become continuous data and both near real time and end of month. And I think Sam was mentioning there's about a 10-minute delay in the calibrated radar rainfall in near real time. We're doing some things to try to speed that up a little bit, but we have some limitations in just how the radars operate and how quickly, well, it's really not very much time on processing, but how quickly those radars spin and give us additional information. So in March of 2019, we transitioned to continuous 5-minute GAR, both in real time and end of month. Where's this data come from anyway? The National Weather Service supports about 160 radars across the country in a program called NEXRAD, and that program was developed in the 1980s, and they also coordinate and share the program with the FAA and the military. But these radars, a lot of the preliminary background work and prototyping was done in Norman, Oklahoma. That's where our headquarters is, and we're understand the basis for that data, how it's created, how it's distributed, what the strengths of the data is, what the weaknesses are. So we primarily rely on reflectivity. So the radars shoot out a beam, reflects from the clouds, and we can then use that data to spatially distribute the rainfall. The radar is very good at detecting that spatial variability of the rainfall. The photo here actually is of the Pittsburgh NEXRAD. One of our visits, we like to visit those NEXRAD sites and understand, you know, who's running them and how they're operated and where they're located. And then this image up here is showing how the radar shoots beams at different levels in the atmosphere. And if we get a clear beam at the lowest level tilt, we like to use that tilt. In Pittsburgh, that lowest level tilt actually hits a water tower, creating an attenuation or a lack of rainfall returns for that area. So we use the second level tilt. So we get up above the water tower and get a nice clean sweep of the atmosphere over Allegheny County. So that radar data combined with what we're seeing in the rain gauge data gives us a better idea of how rainfall is spatially distributed over areas. And there's a little image of the radial bends of the radar. So you can see those aren't 1 by 1 kilometer grids. Those are radial beams. So it's 1 kilometer away from the radar, 1 degree in azimuth. And that's our base data. We quality control at that level. And then we sample that data up into the 1 by 1 kilometer pixels or the weighted basin averages. So why weather radar and why with rain gauges? Well, both sensor systems have strengths and both sensor systems have weaknesses. And we try to use the strengths of each system to help make up for the deficiencies of the other sensor. So measurements are measurements, they have errors in them. Rain gauges, everyone's pretty familiar. There can be splash and heavy rainfall, wind can affect catch. There can be shadows from trees and buildings. There can be mixed precipitation. Gauges get clogged. No matter how well and how carefully they're maintained, they get clogged. So they can be off level. The tipping mechanism cannot register. There can be transmission issues and synchronization issues. Somehow those clocks get off on the rain gauges sometimes. Likewise, weather radar can have some issues that we can compensate for, and quality control on our side, from blockages, like I mentioned, to bright banding, ice crystals in the atmosphere, drift, overshooting the rainfall, advection, causing a kind of strobe-like effect, and power and beam elevation differences. So there are a number of issues that sensors have, measurements have errors, and we try to compensate for those errors using the 2-sensor system. There we go. Here's my summary of that. 2 sensors are better than 1. So what is GAR? It's a time series of rain rates over areas, and it's derived from weather radar adjusted by rain gauge data. So we're removing bias, and that helps us get a better idea of what's happening between the rain gauges, because the rain gauges have no knowledge or way to understand what's happening between them, and the radar gives us that knowledge. So temporal and spatial resolution, that was a great question, Sam, and what we do with that, like I was explaining on the polar coordinate bins of the native resolution of the weather radar, we sample that data up into 1 by 1 kilometer grids, and the 1 by 1 kilometer grid makes it a standard spatial format, which can be useful for periods. If the radar goes down, radars can get struck by lightning, so we can substitute in either another nearby weather radar data, or we can distribute a rain gauge only product if there are periods like that and not have to redefine the grid. So that's great. So we're using that 1 by 1 kilometer grid. And then also when we look at weighted basin averages, we're sampling again from that polar grid to those weighted basin averages. So we don't expect, when you're using our data, for the weighted basin average to be exactly the same as the sampling as the 1 by 1 kilometer grid, because they're both derived from the polar coordinate system. Are you everybody still with me?
Yep, looks great.
Yep.
Okay, so I'm going on to a little bit about the quality control protocol now. So like I mentioned, the things that we do to improve the quality of the radar data, there are things that we do to improve the quality of the rain gauge data. There's statistical removals that we're applying. There's clutter suppression. There are a number of things that Jen and her team are doing to make sure we're giving you the best product that we can. And so what's important to us is this thing that we call a calibrated average difference. And that's plus or minus a certain percentage. So of accuracy. So 11.9, so that's about plus or minus 6% in accuracy. If we hadn't applied our bias adjustment and it just used the radar without removing bias, we would have been at plus or minus 30%. And so we're tracking, and we know that we're improving the data a great deal by using the methodologies that we use. So with that, Christian has a great application that he's providing on your public website at Three Rivers. View and Associates has what we think of as a professional tool that is internally available only by permission. So if you ask Annie, she can add you to that site. But it has a little bit of a different format. We call it a platform because it has a number of applications that are hosted there, but it's extensible. So some of our clients have additional applications that they support on here. So we have one called the Rules Manager, and so it'll automatically send emails, text messages, even phone calls if there are a certain threshold of rainfall or some other parameter is exceeded. We have the depth, duration, frequency that applies both to real-time data or to historical data. We have an easy to download historical links of the data, so you don't have to query for data. You can also download data in very specific formats and aggregations. And let's see, I've got a little image of a snapshot of the maps page that I can go ahead and, this was interesting yesterday. So I was looking yesterday during your rainfall event. I clicked on, we allow you to see the rain gauge, which is the blue line, compared to the radar, which is the orange line. And in real time, it's not uncommon. Like I say, rain gauges get clogged. It's just part of dealing with rain gauges. And we can see when there's a little delay in the rain gauge data, and it's not going up as quickly in time, but it continues to drip out over time when the radar is not seeing any more rainfall. That's something that Jen and her team monitor and watch for. And when they see a clog like that, they might turn that off in real time until they can see that maintenance has been done, because we don't want that to slip through our filters in the system and be able to affect our GAR data. So we're getting good data there, even though on occasion we have a gauge that tries to trick us. See if I can just pop open this site. Okay, so we got a little rainfall going right now. So I'm gonna go ahead and maybe show you a few of the features that are available here.
As Jean mentioned, this is Annie Quinn. I dropped my email address into the chat box. So if you're looking to have access to this more technical tool, as we mentioned, Christian's Make It Rain, the rainfall gauge data website that he walked through is our public facing tool. It's the one that not only you, but your elected officials, managers, even the engineers are welcome to use. Great data, some similar products, but if you're looking for this secondary product and you would like to have that more technical experience, please email me. And Jean, I appreciate this walkthrough. I'll give, if you could, we'll wrap up with you in 1 more minute, and I'll let you show us your last bit, and then we can jump over to Tim.
Yeah, okay, so I'm hitting a little internet issue here on some slowness of loading this, but this is the page where you can request data downloads in a number of different formats, and then you know, similar to Christian's, then download that from the list of data that has been queried.
And Jean, this might be something that we can follow up with an additional meeting where we can focus more on the specialized information for the technical individuals.
Right, and this is, like I said, password protected, and so new users can be added by Annie, and that will give you access, and you can. Jake, are you on the call? So Jake's been exploring a little bit on what he's seen on the site. So if he comments later, he can tell you a little bit what he's experienced. So that's really, my summary of, are there any technical questions on the radar rainfall data and where that comes from?
I don't see any hands raised, so we'll feel free to keep your questions in the chat or even raise your hand even now, but let's jump over to Tim and hear a little bit about the Alakazam perspective on the RainGauge network. So thanks so much, Jean. It was such a pleasure. Even I learned a ton. So Tim, take it away.
All right, thanks, Annie. I'm gonna pull my screen up. Can you let me know if my screen is up for you?
I do see a PowerPoint from Alakazam, so you're ready to rock.
Okay, sounds good.
I'm hitting a little internet problem here, so I'm getting choppy audio, so I'm going to turn it back to you guys, and I'll be quiet here for a bit.
Thanks, Jean. Thank you, Annie. Want to talk a little bit about the current RainGauge network. A little bit of history that I wanted to share with the group. This was a presentation that we gave on the RainGauge network back in 1998, 23 years ago. Back then we had 7 rain gauges throughout basically some of the combined area, spatially distributed. It was pretty good back then. 7 locations, 3 supplementals. We did manual interrogations on these rain gauges, data points in 15 minutes. And the period of record for those 7 rain gauges was 1993 to 2001. We also had historical data going back 92 years at that point. Where we're at now, we have over 30 rain gauges throughout Allegheny County, and a rain gauge in Westmoreland County. I'm not showing Richland on here, but to provide the information that Jean utilizes to give us the radar rainfall data, we had to have a larger rain gauge network. The original rain gauge network was within the Alakazam service area, but then we expanded it to outside the service area so that we could get this radar rainfall throughout all of Allegheny County and our customer municipalities. So we have over 30 rain gauge locations. Alakazam staff, we're the ones now responsible. Originally, Harry Geis from Three Rivers would maintain these rain gauges, but after Harry retired, Alakazam staff took on the responsibility to maintain them. Per our consent decree, these rain gauges, which are in the consent decree, excuse me for a second. The rain gauges are in the consent decree. We have to do annual calibrations. Our staff does that. And most of the original setup of the rain gauge network was supposed to telemetry the data to a centralized computer. Over time, maybe we had a few manual interrogations, but for the most part, it was all telemetry. The data points still 15-minute intervals, and the period of record of this rain gauge network goes back to 2001 to now. Where are we at now, though, with the rain gauges? The rain gauges that were originally purchased by Three Rivers Wet Weather many years ago, they've exceeded their lifespan. They've been properly maintained, but the equipment that provides the communications is no longer supported. It's outdated. We tried to find the equipment and it's just not there. And as a result, with the lack of communications, that means that there has to be more manual interrogations to these rain gauges. So we've been budgeting for new equipment, and last year in 2020, as part of the authorization for Three Rivers Wet Weather, we authorized Three Rivers Wet Weather the budget to purchase new equipment, and with this new equipment, we should have a better communication network, to make this state of the art. Right now, we're pretty much going to keep with the existing rain gauge locations. There is one location in Bell Acres which we would like to move to what seems to be a void spot in Allegheny County around Deer Township. So that'll be the one change, but Joe Fedor, who maintains these rain gauges, he's worked with Gene, and I believe that there will be no loss of data integrity by moving Bell Acres to there. As a matter of fact, it should enhance the radar rainfall. So, in summary, Alcosan is going to be working with Three Rivers to get new equipment. This new equipment will be installed throughout the service area, for the most part in the same locations. If a location may need to change for whatever reason, site conditions or whatnot, we will note that, but any changes outside of Bell Acres should not be a dramatic change in the location and the data integrity of that particular location. If there are any questions, I'd be more than happy to answer them right now. Rick, is that your hand up for me?
Yes, sir. Got to go to the guru.
What's the question?
I was wondering, do you have any interest in additional rain gauges that maybe municipalities have staged? I know it would be dependent on the quality of the rain gauge, but I'm just wondering if that would help your network, or if you think just you've got a good network, no need to solicit back.
I think I appreciate the thought, Rick. I think right now, in a situation like that, maybe not so much using that for, calibrating the radar rainfall, but maybe, and I'll throw this out to Gene, maybe utilizing those rain gauges possibly as a validation point to kind of enhance the integrity of the network. Right now, if we said we'll take municipal data also, that potentially can make things more complex. Just in the logistics of getting the data to Gene. With the communication, with the new equipment and the communications, we're trying to speed up the communication between the rain gauges and View. And right now, the communication's fine, but it definitely can be better because the communications for a lot of the rain gauges are just no longer there. And so with the manual interrogation, then Joe has to go and send that information out to Gene. I want to get this back to something where all the information as well as possible gets to Gene and the team as near to real time as possible. But I don't want to discount the municipal rain gauges. I think that their function could be more of a validation point to ensure that the radar rainfall data is truly representative.
Yeah, it makes sense. I just wanted
Gene,
to throw
do you have
that
any
out.
thoughts on that?
Yeah, well, we would never turn away data just because data is great and it always does improve our system, but to use it for validation is a great idea as well. And Richard, we would appreciate any of your feedback if you are using it as validation of what you see with that. It'd be interesting to see where your rain gauge is located in relationship to maybe the nearest Alcosan rain gauge. Because rainfall can be correlated in space and time, and so if it's quite close to another rain gauge, it probably wouldn't contribute very much. But depending on how many gauges are out there and and how you could share them if you wanted to put a radio transmitter on it that would actually go into the Alcasan system if they decided that they wanted to accept that data into their system. That would be something that could be explored.
Yeah, the intent was to let you know that there are municipalities that have rain gauges out there, and that if it would serve as, you know, a betterment on the data that you're providing, or even providing additional data, validation or direct data, that maybe a request out to the municipalities could be, hey, if you have anything, let us know what you have, where it is, what the equipment is, and then you could piece together whether you wanted specific locations or not. So that was really it. Just the thought that I know there's municipal rain gauges and even weather stations out there that might help you.
Absolutely. Thanks, Rick. Are there any other questions?
Yes,
Okay.
there's one in the chat for you, Tim. It's, what is the time frame? This is from Mark. What is the time frame for installation of this new equipment and integrating the new data into the system?
Right now, I wish Joe Fedor was not on vacation, because he'd be the appropriate person to answer that question. I believe the data, or not the data, the rain gauges, I believe, are en route. We had to purchase over 30 rain gauges, so, and it's not inexpensive equipment. But I'm hoping that this network can be up and running before the end of summer. I wish I had a better answer for you. So for now, we're until we get the new rain gauges installed throughout the service area, and until we get all the rain gauges installed, and making sure the communication network is working properly. Once we have everything completed, then we will turn everything over. But I don't want to do this piecemeal. I would prefer that we get everything in order, everything's working properly as expected, and then once we have that in place, we would make a clean change to the new information. And by a clean change, it means that the end users should not be able to notice a difference at all. It's not on the user end. It's on the data acquisition end. We have to make these improvements to be sure that the gauges are now new and have a long lifespan, and the equipment for communications is updated and is not going to be outdated anytime soon.
Tim, just to follow up a little bit, that the schedule has been planned that we should, it's anticipated that installation would be at the end of July, but last conversations with the supplier and Joe could be a holdup because of the microchips that are holding up a lot of things throughout our country and world lately, but everything seems to be on plan, and again, it should be seamless, and it is a very costly thing, and again, I just want everybody to know, thanks to Tim for pushing this, and for Alcasan to fund it. For the long term, it's going to be great. We got 20 years out of the first system. Hopefully we get 20 plus years out of the next system, and so we are moving forward with that as quick as we can.